Thanks so much, Asha, for the warm introduction. It's really a pleasure to be back at Princeton, and especially to have this interdisciplinary group of people from demography and sociology and economics. Wonderful to see everyone interested in these important questions. So I'm going to start today with a map that's been on my mind for the past 10 years. I think a number of you have seen this map, but let me just, for those who may not have seen it, take a minute to describe how we've constructed this map, what I think we learned from it, and why it sets the stage for what I want to discuss today. So this map shows the geography of upward mobility in the United States. We constructed in a paper we wrote about 10 years ago, where we took data from anonymized tax returns covering essentially all children born in the United States in the late 1970s, early 1980s, about 20 million children. We mapped those kids back to the county in which they grew up in this version of the map, and linked them to their parents. And using that data, we construct a very simple measure of children's chances of rising up and achieving the American dream of upward mobility in some sense, where we asked, suppose you grew up in a low-income family, a family which I'm going to define as being at the 25th percentile of the US national income distribution, which earns about $27,000 a year. That's the 25th percentile of household income in 2015 dollars. So say you grew up in such a family, and we followed you over time, what was your average income when we look at your 1040 tax return in adulthood? So for example, you can see that in the Philadelphia metro area, kids who grew up in families making $27,000 a year, on average in their mid-30s, were making about $31,000 a year. And we similarly construct that statistic for every county in the United States. And we color the map so that the red-orange colors are places where kids have poorer outcomes, where they're less likely to rise up. And the blue-green colors represent places with higher levels of upward mobility. So if you start by looking at the scale on the lower right-hand side of this map, you can see that there's an enormous amount of variation in children's chances of rising up in different parts of the United States. There are some places, like the center of the country, look at a place like Dubuque, Iowa, West, where kids growing up in families making $27,000 a year are making $45,000 or even $50,000 on average in the next generation. There are other places in America, like Charlotte or Philadelphia, much of the Southeast, where kids growing up in families with that exact same income level of $27,000, one generation later, are not doing much better than their parents were when they are in their mid-30s. And so a tremendous amount of variation in your chances of rising up across different parts of the US. So this map has been of interest to our team and Opportunity Insights and a number of others in the field, I think for two reasons. First, from a policy perspective, there are a number of cities across the US where I've given talks over the years where people are interested in understanding, what are people doing in Salt Lake City or other parts of the country where we're seeing higher levels of upward mobility? How can we replicate that in Atlanta or in Charlotte? How can we turn the red colors in this map into green colors? There's been a lot of policy interest in increasing upward mobility in lower mobility areas. Now, in order to answer those policy questions, of course, the second key thing that this kind of data is fueled is an ability to understand the science of economic opportunity, if you will. This kind of granular information gives us a new lens to study the determinants of economic opportunity, where we can do things like look at people who move from one area to another, as your colleague Aurora Durnoncourt has done, we've done in our team and a number of others, or looking at the correlates of these differences in mobility across areas. What is it that makes some places have lower rates of upward mobility than others? This kind of information has led to many, many papers that have allowed us to make progress in understanding those questions. So motivated by that two-part framing of developing a better scientific understanding and ultimately informing policy, the way I'm going to structure this talk is in the first part, show you some recent work we've done that gives us a better sense of the drivers of economic mobility. And the second half turn towards policy interventions. And there I'm going to focus in particular on a certain set of programs and a set of methodological issues that relate actually to topics that have been discussed here at Princeton for many decades. So let me start on the first part, on the scientific side, understanding the determinants of economic opportunity, by showing you some data from recent work we've done with my colleagues, Crystal Yang and Will Dobie, who are going to be your colleagues soon, as well as Benny Goldman at Cornell, and Sonia Porter, where in this paper that we put out last year, we essentially exploit the gift of time, the fact that 10 years have passed since we did that initial study. And that now allows us to examine how these patterns of economic mobility are changing over time. So what we're doing here is now taking data on kids first born in 1978, which is the earliest time point we're able to look at. That's the first birth cohort here. We're going to construct exactly the same statistics that I talked about on the first map, but it turns out to be useful, as you'll see in a second, to subdivide the data by race and ethnicity as well. So here, I'm showing you the map that I showed you before for kids born in 1978 for white children born to low-income parents. And you can see a pattern that looks qualitatively quite similar to the first slide, with much lower levels of economic mobility in the Southeast, higher levels in the rural Midwest, and so on. So now let's look at what happens over time to this map when we reconstruct it for white children born to low-income parents in 1992. Same color scale, exact same statistics. You can see that the red colors have spread across the United States. It used to be the case that if you were a white kid growing up in a poor family in parts of California or the Northeast, you had a pretty good shot of reaching the middle class or beyond. That is no longer the case, as you can see. And so in that sense, opportunity has truly receded for many low-income kids, in particular low-income kids growing up, white kids growing up in low-income families. So that is one important pattern in the data. Now, why do we subdivide the data by race? It turns out these patterns vary quite significantly across racial groups. If we now reproduce the same pair of maps for Black Americans, now it's the exact same set of statistics here, two changes. First, much of the map is blank. That's because we don't have a sufficiently large Black population in much of the country to construct these statistics. In the parts where we do have an adequately large Black population, we're constructing exactly the same measures of upward mobility, but we're changing the color spectrum here for a reason that will become evident in a second, where the purple colors represent areas where Black kids are less likely to rise up, and the peach-orange colors are areas with higher levels of upward mobility. So this is what the picture looks like for Black kids in 1978, born in 1978. Here's the corresponding map for Black kids born in 1992, where you see a mirror image of the patterns that we saw for white children going in the opposite direction. Opportunities improving across the board for Black kids growing up in low-income families. They have better outcomes on average than they did in the past. Some of the lowest opportunity areas, like you see in the Southeast, you now see higher rates of upward mobility. And so in that sense, if you put those two facts together, you're seeing some racial convergence in economic mobility, a pattern of shrinking race gaps. You also see, not shown in these maps, but we show in the paper, a pattern of growing class gaps. It's becoming more and more important in America. If you're born to rich parents or poor parents, I'm showing you the data here for kids born to low-income parents. If you look at the data for kids born to high-income parents, you can see that they're doing even better in 1992 than they were in the past, pulling further away from kids born to low-income families. So class is becoming more important. Race is becoming a little bit less important. Now, in documenting that fact, it is very important to note that while racial gaps are shrinking, they still remain very large in levels. And so to make that evident, and now you'll see why we've put these maps on two different color scales, if we just put side by side the data for kids born in 1992 for Black children on the left and white children on the right, you can see, if you look at the color scales at the bottom, that they are completely non-overlapping. The very best places, even in 1992, even after that improvement for Black children, the very best places for upward mobility look significantly worse in terms of their prospects than the very worst places for white children. And so I think those two facts that you see very clearly in the data, in my view, capture some of the tension and broader political discourse that you see in the United States, where on the one hand, it is true that kids in low-income families, white children in particular, are struggling more than they were in the past. On the other hand, the racial divide remains extremely large and racial disparities remain quite pronounced in the United States. And so motivated by these descriptive facts, what I want to do next, and the reason I'm showing you these data, in addition to being useful to understand what opportunity looks like at present in the United States, is that this gives us further lens, a sharper lens, if you will, to study the determinants of economic mobility, where now we can not just make cross-sectional comparisons, as we were able to do with that initial map, but we can start to understand what is driving these changes in economic opportunity for different subgroups, and use that as a way to understand more generally what the determinants of economic mobility are. So, yeah.
Again, they're born in the US, so they are kids, but they're
Self-reported in the census. So straight from the census, the kids self.
we can't distinguish them from like immigrants versus
You can, we're not doing that there. So it's the sample, and let me just say a little bit more about the sample. So this is children raised in the United States who we can link back to their parents. So if you came to the US, say for college, and your parents are not in the US, we're not going to see your parents in the tax data, you won't be included, and the else is simple. So think of it as kids raised in the United States, basically. Great, thanks for clarifying. So let's now use this data to understand the determinants of economic mobility. In this paper, what we do is look at what factors can explain the changes that we're seeing for Black kids and for white kids across different areas in the US. It turns out that there's one variable that pretty much entirely explains the differences in the variation in the maps that I just showed you a second ago. And that variable goes back to work of the well-known sociologist, my colleague, William Julius Wilson, on employment rates in the neighborhoods where kids are growing up. So to show you that relationship, let me turn to this plot here, where on the y-axis, we're plotting the change in average household incomes between the 1978 and 1992 cohorts for kids growing up in low-income families. So basically the difference in the two sets of maps that I was showing you here first for white children born to low-income parents. And what we're doing is presenting a bin scatter plot of the data on those changes in upward mobility by county versus the changes in parental employment rates in those same counties. So you can see there's a clear positive relationship here. We've divided the X variable into 20 equal-sized bins, and we're just plotting the mean of the X and Y variables within those bins to construct this chart. So you can see if you come over to the right side of that, that dot at -5, places where employment was not falling very much for white parents in the parents' generation, you see that in those places, kids in the 1992 cohort are doing just about as well as kids in the 1978 cohort. If you go all the way over to the far left, those are places where employment's falling very rapidly for white parents. And you can see that in those places, kids in the next generation are experiencing much lower levels of upward mobility. So there's a clear positive relationship here. If you're growing up in a county where your parents' generation is doing better in terms of employment rates, you yourself have better outcomes in the next generation. You're more likely to rise up. So that's the relationship you see for white children. If you now plot the same dots, same series for Black children, you see exactly the same pattern, except it's shifted over to the right. We already saw from the maps that I showed you before that outcomes were improving for Black children in terms of upward mobility relative to white children. That's why the green dots are above the orange dots vertically. They also are over to the right because you see differential trends in employment rates for white versus Black adults, as is known from prior work over recent decades in the United States. Now, what's striking about this plot is that the entire set of data across races and across counties can be explained essentially by a single variable. In economics, we call this a one-factor model. Basically, a single factor that seems to fully explain the patterns that we're seeing by race, by class, and also by geography. And that variable is changes in the employment rates in the prior generation. So what I want to do next is dig into why there's such a strong connection between the outcomes of children in a given generation and employment rates in their community in the prior generation. One very simple explanation you might have in mind is that this is just picking up something about what's happening in your own family. So if you're in one of these dots on the far left, where it's like a town where the local steel plant has closed and lots of people have lost their jobs, maybe your own parents lost their job. And obviously, if your own parents lost their job, maybe you think that has a negative effect on your own outcomes as a kid. So we can examine that by replicating this plot, looking at children whose own parents remain employed throughout the period we're studying. So this is a set of kids whose own parents did not lose their jobs. plotting the change in their outcomes versus what's going on in their county for their racial subgroup. And you can see the relationship looks exactly the same. So it doesn't seem to be about what's happening with your own parents, even controlling for your own parents' employment status. There's a strong link to changes in community level employment rates. So why might this be? I think there are two different natural explanations to think about. The first, from a statistical perspective, is one of correlated shocks to labor demand. So what's one simple story for what's going on? In an example of the steel plant closing in a particular town, if you as a kid were hoping to get a job in that same steel plant, then that local labor demand shock might negatively affect your own employment prospects, and you might end up with a lower income in adulthood. That would just be the same shock as affecting both the parents' generation and the kids' generation, sort of a mechanical explanation for why we're seeing the plot that I just showed you. A different explanation, which I view as more of a sociological one, which goes back to the kind of ideas that Bill Wilson was thinking about, is an environmental exposure effect. The idea that growing up in a community where people are not working might have an adverse effect on your own outcomes the future, not literally because you couldn't get a job at that steel plant, but because maybe you drop out of high school, you end up pursuing a different career path, you see Pat here, you maybe get involved in crime, and you end up going down a different path entirely. So to distinguish these explanations, what we're gonna do is, I think something quite intuitive. We're gonna study kids who moved to improving versus declining areas at different ages. And the logic is captured very simply in this pair of charts here. So let's replicate the same analysis that I was showing you before, looking at the link between changes in children's outcomes across cohorts and changes in county level parental employment rates. But do that looking at a set of people who moved to the county where we're looking at changes in employment rates when they were young, before they were 8 years old. So you can see for those kids who got to those counties where employment was going up a lot or going down a lot in the parents' generation, at young ages, there's that same kind of pattern that I showed you before, a strong link between changes in parental employment rates and changes in kids' outcomes. Now, if I do that exact same analysis for kids who moved at older ages towards the end of childhood, like in their teenage years, you see a much flatter relationship. Now, this evidence suggests that what is going on here can't be the simple correlated labor demand shock explanation, because if it were, that should predict that the orange line would also be upward sloping. You're in the same place, before you're entering the labor market. If the local steel plant closed and you were trying to get a job there, that would affect you as a 15 if you got there when you were 15, just like it would affect you if you got there when you were 5. In fact, as you can see, we see in these two plots, and more generally when we look at this age by age, there's this very clear age-dependent exposure effect. The earlier you get to a place where employment is falling, the earlier in your childhood, the worse you do in the long run, which seems more consistent with the childhood exposure effect, that there's this dosage effect with the environment in which you grow up really matters. Now, to draw that conclusion rigorously, the identification assumption in the background is that the potential outcomes of the kids who move at younger versus older ages to these declining versus improving places have to be comparable. One way, we assess that in a number of ways in the paper. One intuitive way to do that is to look at siblings within the same family. So you're taking out any family level differences between people who move at younger versus older ages. And what you can see is that when siblings are far apart in age, and you move to a place with improving employment, the younger kid starts to do better than the older kid. Whereas when siblings are close in age, you see no such difference in their outcomes emerge. And so basically those same patterns that I've been showing you on age-dependent effects of exposure to places with declining employment, they emerge within families, strongly suggesting that this is really about the causal effects of environment rather than some unobserved heterogeneity across families. So now as a next step, having established that it seems to matter where you grow up, and in particular, what is going on in the economy, overall levels of employment of the adults in the area where you're growing up, that plays a key role in shaping economic mobility by race, by class, across geographies. The next thing I want to do is dig one layer deeper and try to understand the mechanism through which that mechanism is emerging. And here again, I think there are two natural mechanisms to think about. One is what I'll call a social interaction mechanism. If you grow up in a place where lots of people are working, maybe that changes your own aspirations. It changes your own employment opportunities. As you all know, many jobs in the US are obtained through referrals. If you're growing up in a community where people have good jobs, then you yourself are likely to get that internship or job that puts you on a better pathway. So that's one class of explanations. Another class of explanations is about economic resources. If I'm in a place that is declining economically, maybe the schools have less funding, there's less funding for local programs. From just that economic mechanism, you would expect perhaps kids end up having worse outcomes. So to test between these two explanations, what we're going to do is now turn to another source of data that exploits differences in friendship patterns across groups. So let me start with one simple version of this. So here we're using data from Facebook. We're collaborating with Facebook on the core data science team at Facebook to look at how social networks affect outcomes in various ways. Here I'm showing you one analysis from that collaboration, which first documents just a very intuitive pattern. What we're looking at here in this orange series is your probability, the fraction of friends you have in the same grade as you in high school versus one grade below, one grade above, two grades below, two grades above, and so on. And you see this very clear tent-shaped pattern, which if you introspect about your own high school experience, I think is very intuitive. You probably have more friends in your own grade than you did in the grade above, a grade below, two grades above, two grades below, and so on. So why am I showing you this? If it's about the social interaction hypothesis, we would expect that the employment rates of the kids you interact with more, that is kids in your own grade, should matter more than kids in the surrounding grades. If it's about resources in your school, you would expect, given how school financing works, that would be more slow moving. The parental employment rates of kids, a year older or 2 years older, you would think would matter just about as much as the parental employment rates of kids in your own grade. So what we can do is replicate the analysis that I was showing you earlier, regress changes in kids' outcomes on changes in parental employment rates by cohort. So how do the parental employment rates of kids in your own grade versus the grade below, grade above, and so on predict your outcomes? And you can see you get a very similar tent-shaped picture, exactly like the pattern of friendships. It's the kids in your own grade whose parental employment rates matter the most. We do a number of other variants of this, exploiting patterns of homophily in the data. So kids are more likely to befriend kids of the same racial background, for example, or same class background. And you always find this pattern that it's the parental employment rates of the people you're most likely to interact with that are predictive of your outcomes, which seems to point to the social interaction mechanism as being central. Not saying that economic resources don't matter, but certainly social interaction seems to be a key part of it. Let me show you one final piece of data that I think further underscores that point, where separate from this paper, we've been doing some work trying to understand social connections in the US and how they relate to economic mobility. So this is from that other analysis where the map on the left is the map of upward mobility constructed using tax record data that I showed you on the first slide. The map on the right looks very similar, but is completely different. It is a map constructed using Facebook data on 72 million users of Facebook between the ages of 25 and 44, covers about 84% of the US population. So it's not universal coverage like the tax data, but pretty close in that age range. And what we're doing in the map on the right is constructing a very simple measure of social capital that we're calling economic connectedness. It measures the fraction of among below median income people. It measures the fraction of their friends on Facebook who have above median income. So in the map on the right, the green colors represent places where low income people have more high income connections, and the red colors are places with more disconnection by class. And you can see, very clearly the map on the right looks incredibly similar to the map on the left. This turns out to be the single strongest predictor of economic mobility that we or anybody else has identified. And it actually explains a number of other prior patterns that have been identified in the literature. Some of you might be familiar, for example, with the Great Gatsby curve, which was popularized by your colleague Alan Kruger, the link between inequality and social mobility. That turns out to be, in a statistical sense, completely mediated by this economic connectedness variable. Once you can control for economic connectedness, there's no longer a link between inequality and rates of upward mobility. So there appears to be a very strong correlational connection here, both at the national level and at the local level. So here we've zoomed in on the data in this area, looking at the data census tract by census tract on rates of upward mobility in the New Jersey, New York area, and similarly, the data on cross-class interaction. And you can see those two things look incredibly similar to each other, even at that hyperlocal level. So this, of course, is all correlational. You know, there seems to be a strong link consistent with the data that I was showing you from the analysis of changes across cohorts between being connected to more people who are from high-income families and your own chances of rising up. Now, in the remaining time, is talk about how we can take these kinds of scientific findings to think about policy interventions to increase economic mobility going forward. The way we are structuring our thinking on those issues in our team is in three areas, which I think follow naturally from the set of results that I've briefly shown you in the past few minutes. So in particular, if I were to summarize in a nutshell what we've learned from a decade or so of research on economic mobility using these large-scale data sets, it's that the determinants of rates of upward mobility are highly local. It's about the exact neighborhood in which you grow up, from something like birth to early adulthood, linked to factors like who you're connected to, the quality of local schools, and so on. So if you have that view of the world, I think you would naturally think about three different ways to increase opportunity going forward. The first is to reduce segregation. If you think about the map of the New York, New Jersey area that I showed you a second ago, in many cities, there are often places that are a couple miles down the road where you see kids have much better outcomes. So a natural approach that you might think of to improve opportunity is to use affordable housing or housing vouchers, or give people access to those high opportunity neighborhoods, essentially moving the opportunity approach. I think that approach has a lot of promise. We've done a lot of work on that space. A number of others here have done work in that space. It, of course, has limits to scale. You can't move everyone, and if you try to move people on scale, there might be general equilibrium effects that dampen the gains from those moves. And so that motivates focusing on a second area of place-based investment. Can we take the red-colored areas in the maps that I've been showing you, turn them into green colors by making place-based investments, perhaps in the schools or by rebuilding local housing and so on? We've done quite a bit of work in that space as well, especially recently, where we're finding certain programs like the Hope 6 Neighborhood Revitalization Program. It's another paper we'll put out in the next few months. Really seems to have had that Hope 6 program spent $17 billion revitalizing high poverty public housing projects. We're finding quite significant gains from those investments that relate to, again, social interaction effects and so on. So I think there's a lot of promise in that space as well. What I'm going to focus on here, could talk about any one of these. I'm going to focus on the third one, just in the interest of time, to pick one domain that I think connects the interests of a number of folks in the room, which is this third bucket of higher education and workforce training. After age 18, of course, the key touch point for most kids is not the home in which they live, but the institution of higher education they might attend or a workforce training program they might participate in. And my view is that there's a lot that we can do in this space as well as the other two to improve prospects for upward mobility in the United States. And so I'm going to go into this in greater detail in the remaining time in the talk, both to show you substantively what kinds of programs we think might work in the space, and also emphasize a set of methodological issues that I think are very relevant, thinking about understanding which policies can be effective more generally, even beyond the higher education workforce training context. So to start, I'm going to focus on one particular program, one particular job training program that has received a lot of attention in recent years as being quite successful. It's called Gear Up. It's a program that started in Boston, now is spread across the United States. Trains about 4,500 people a year in a one-year program, which, as you can see at the bottom of the slide, consists of three components. There's a traditional skills training component, where we teach you a certain set of skills. Could be IT, could be financial operations. That looks like a canonical job training program of the type, that was implemented widely in the 80s and 90s and is implemented in many states across the United States. There are then two other elements that are extremely important. There's an internship element, where unlike in traditional job training models where we say, here's a set of skills, good luck now using them finding a job on your own, Here, we're actually going to connect you with an internship in a specific firm that is looking to hire for exactly that profile. So they partner with companies like Bank of America, or State Street Bank, things like that. And they will have a certain set of slots for people that are going to bring as interns through this program. And then if all goes well, you'll get a job at that firm in that sector. And, that's the month. Okay. So Year Up was evaluated in a randomized trial conducted by other scholars back in 2014. Here, what we're doing is taking the data from that randomized trial and linking it to the tax record data that I was using in the first part of the talk. That trial was conducted in 2014. So here we're just plotting mean W2 wage earnings for the treated group in green and the control group in orange. As you'd expect before, given randomization, prior to 2014, those two lines are perfectly on top of each other. Then in 2014, when people are participating in the Year Up program, the people in the treatment group experience a dip in earnings relative to the control group, which makes sense because they're in training and they're working less at that point. And then afterward, you see a very clear jump in earnings that is sustained for the subsequent decade. And when we look at other versions of these programs, these effects seem incredibly durable, where you see about a $9,000 a year earnings impact that lasts over time. So this looks incredibly promising. This program costs about $12,000 upfront that they have to raise philanthropically. If you think about the social rate of return here, an increase of $9,000 per year in earnings, this looks like an incredibly attractive program from a social point of view, something you would think we should be scaling up quite a bit, perhaps. So now, in thinking about these kinds of job training programs, this is one program that we've studied in detail using a randomized trial. Seems very promising. But this is only one of, it turns out, 5,000 different job training programs that we have in the United States, some of which we've just listed the names of here. And if you think about the approach taken there of running this trial, ideally what we would say as scientists is to figure out which of these things work, we would do a randomized trial analysis like what I just showed you for every one of these things, and then figure out which works, which doesn't, and try to invest more money and scale up the ones that look more like Year Up. So that obviously is an incredibly challenging undertaking, which is why most of these things, 99% of them, have not been evaluated with randomized trials. But in my view, that also, creates a big challenge for our field because it's very hard to know what's working and what's not working, and that may be part of the explanation for why Year Up, even though it's at a fairly large scale now, 4,000 people a year, in the grand scheme of things, 4,000 people is nothing relative to the scale of the population and the challenges we're facing in the country. So we would like to have better information on how all of these other programs are working in the context of workforce training here, and of course, much more generally. So this issue of how to evaluate training programs and evaluate programs more generally is, of course, something that economists have grappled with for a long time. And in particular, and I'm especially happy to be presenting this here at Princeton, is something that people thought about very carefully in the labor section here at Princeton going back to the 1980s and 1990s, people like Orley Ashenfelter, Bob Lalonde, David Card, and others, which is really the origin of the credibility revolution, where many of you, the economists here will know, and others as well. The famous paper by Bob Lalonde in the AER in 1986 really just tried to assess exactly in the context of training programs whether observational methods could be helpful as a way to evaluate the types of programs that I was showing you on the previous slide. So one way you might think about it, is I think the way Lalonde and others were thinking about it at the time, is we can't run an experiment to evaluate every single program. Can we use observational estimators like matching or regression or propensity score weighting to get some understanding that's maybe approximately what we would get from an experiment? And maybe that's a scalable strategy. And what Lalonde concluded in this very influential article, I'll just read out one of the key lines from the abstract: non-experimental econometric procedures by observational estimators do not replicate the experimentally determined results. And that, of course, led then to the focus on randomized trials, quasi-experimental methods, and so on over the past 2 or 3 decades in our field. Now, I want to revisit these ideas, and I want to revisit them from the perspective of now having big data, because it's not a theorem whether matching works or not. where any observational estimator works or not, it's going to be, of course, a function of the data you have potentially. And so what we're doing in some ongoing analysis at the moment is revisiting the work of Lalonde, essentially that same sort of analysis, but rather than implementing the observational estimator in the current population survey, which had a sample of about 16,000 people, and that limited, the quality of matches you could get, what we're going to do is start from the tax data on 170 million people, and then we're going to try to match people quite precisely. So for each person in the treatment group of the Year Up program, we're going to find everyone who has exactly the same characteristics along 5 key dimensions that actually Lalonde and others also examined, but we're able to do it in a more granular way. We're going to match on exact age, sex, race, state, and earnings trajectory in the 3 years before you participated in the program. So basically, we're going to try to find somebody who looks exactly like you on all of these dimensions simultaneously. It's a fairly high dimensional set of things, which is why it's important, as I'll show you in a second, to start with a data set that has 170 million people to begin with. So then we're simply going to compute the mean earnings for this matched control group, so synthetic control essentially instead of the randomized control, and then do the Lalonde sort of exercise of ask how well does the matching estimator perform relative to the experimental estimator. I'm going to focus on this exact matching procedure here for transparency. There are other methods you can use, other observational estimators that get you to basically the same place, but just for concreteness, I'll focus on this here. Okay, so let's go back to this Year Up randomized trial plot that I showed you a second ago, and now overlay a third series, which is what you get with this matched control group with that exact matching style. So just to be concrete, that black line, what we've done is for each of the 2,000 or so people on the green line who participated in the program, we find somebody that looks exactly like them on the 5 dimensions I listed, and then plot the average earnings for that. You can see that that looks practically identical to the orange randomized experimental control line, right? And so what that means is, in this case, if I were to form a treatment effect estimate without using the experiment at all, just comparing the outcomes of the treatment group to the black matched control group, for which I did not need to run a randomized experiment, I would get this series of treatment effects here, which would be 0 prior to the experimental intervention, a dip of minus $4,000 while you're in the program, and then an increase of about $8,000 to $9,000 afterward. I can compare that to what you get from the randomized trial, and it looks incredibly similar in terms of the profile of treatment effects. And if you add confidence intervals to those estimates, you couldn't reject the null hypothesis that they're the same, okay? So that is one case study. It's an N of 1, where it looks like matching actually seems to work pretty well. So we were encouraged by that. So now we're in the process of trying to do the same thing for a number of different job training programs. And let me show you our current, where we are at the moment. So here now you have 13 dots, 13 different programs and sites where RCTs have been run in the past. We're showing the randomized trial estimates on the y-axis, and we're plotting them against the matching-based estimates on the x-axis. And you can see these things are quite well aligned. In particular, there are some programs that generate $20,000 a year, remarkably $20,000 a year earnings and past. You would have figured that out just by looking at the x-axis without having to do the experiment. There are other programs on which we spend just as much money. Unfortunately, they generate 0 impact on earnings. And you would have also figured that out without running the randomized trial with the matching approach. More generally, rather than now defining the question as testing the null of whether these matching estimators work or not, you can measure the quality with which they work in some sense by estimating the mean squared error of the matching estimate relative to the ground truth randomized trial. What does that look like visually? It's just looking at the vertical deviation of these points from the 45-degree line. So how much do the randomized trial estimates differ from the matching estimates? And asking in some sense, what's the average error there? It turns out if you compute the mean squared error of the raw RCT estimates versus the matching estimates, you get an estimate of $1,272. Now, a big portion of that deviation is actually just coming from finite sample noise in the randomized trial estimates themselves, right? You wouldn't expect these dots to line up perfectly, because the sample used in the randomized trial is only so large. You can assess how big that error is just from the standard errors of the estimates for in the randomized trial. And it turns out it's on the same order of magnitude, which basically implies that the matching is pretty much picking up the population level like in this context. It's working quite well, in other words. It's a way to get a sense of which programs work, even without having to run randomized trials. Let me make two final points before taking questions. So you might wonder, connecting now back to the work done here at Princeton almost 40 years ago now, why are we reaching a different conclusion at this point? So what's different? So obviously we have more data. Why does that matter? It could matter simply because we have bigger samples. So simply having more data is going to increase the precision of your estimates. It could also matter because we are fitting a much more complex model, allowing for all these interactions, capturing the nonlinear wage trajectory and so on. Whereas prior work fit pretty low dimensional models. So the Lalonde work just fit linear models because you couldn't do anything other than run a linear regression when you had the 16,000 observations in the CPS. So which of these things is important? Let me give you a sense of that with this chart here. So as I showed you, the kind of naive estimate of the root mean squared error, when you do the non-parametric exact matching, you get with those 13 programs is $1,272. Suppose you instead did exactly the Lalonde model. You took a random sample with 16,000 observations, which is the size of the data set he was working with, fit a linear model with linear earnings and so on. You can see that you would get triple the mean squared error. So you would do much worse in terms of predicting the randomized trial estimates. And if you then, simply increase the size of the sample that you're working with, and now use a 5% sample of the national data, so 9 million observations instead of 16,000, but fit that same low dimensional model, you get essentially no gain in terms of mean squared error. So what's happening basically is when you have a very large data set, you can fit a much more flexible model. And that allows you to do matching much more precisely, which allows you to get a much better sense of what the true treatment effects are. That's our understanding at the moment. Let me skip some more details in the interest of time, where we do this in a more systematic way, varying the lasso penalty parameter to make exactly that point. I'm happy to discuss further afterward if people are interested. And just end here by showing you an application of why I think this kind of methodology can be quite useful in this context and the social sciences more generally. So now, once we validated this matching estimator, where we don't need to use the randomized trial anymore, it can help us learn about the effectiveness of what kinds of programs work, on a much greater scale. So to illustrate that, I'm going to return to the Year Up program as a case study. For Year Up, they ran the randomized trial in 2014, but they were running the program starting in 2008, and they continued to the present date. So at the moment we were doing this analysis, we had data from Year Up, just observational data on who participated in their program from 2008 to 2018. So what we're going to do is apply the matching estimator to that observational data for different vintages of the Year Up program, the version that was running in 2008, 2009, and so on. You could not have known about their effectiveness from the randomized trial run just in 2014, obviously, but with matching, you've kind of taken off the handcuffs. You could look at a broader set of program effects. So I'm going to show you here the treatment effects of different vintages of the program, starting with this purple dot here for people who participated in the program in 2014, where you'll recall from the slide I showed you before, the program had a $9,000 treatment. So what we can do now is add in the estimated treatment effects of the program as it operated for people who are enrolled in 2008, 2009, 2010, and so on. What you see is this very interesting upward sloping pattern. The program has become considerably more effective over time. In a way, it's a good thing they didn't run a large randomized trial in 2008, because they have concluded the program didn't have that big of an effect and probably would have helped them ramp up. There you estimate only a $3,000 treatment effect. By the end of the period right before the pandemic, they were increasing people's earnings by $12,000 on average, even better than what they found in the RCT. Something you could not have figured out just using the RCT. And let me note, given that mean squared error estimate of about $1,200, in some sense, you can get a notion of statistical significance or confidence interval here. You can be quite confident that $12,000 effect that you're seeing at the end is not just because of some mismatch random error different from the $3,000 effect at the beginning. It's quite clear that there's a real upward trend here. What's more, these effects vary not just in the aggregate, but across sites in interesting ways. So this is data from one city where Europe is operating, where you see the clear kind of learning by doing improvement over time. Here's data from another city where, for whatever reason, the treatment effects are flatlining and the program is not getting better over time. And so this is really useful. We've shared this information back with them. They can figure out how to retool in city B to match what's happening in city A and so on. From a researcher's perspective, what's valuable about having all these different estimates is we can now take that and have more information to try to understand what makes some job training programs more effective than others. So what we've done here is taken 160 different estimates across sites and time periods of the treatment effects of year up, put that on the y-axis, and plot that against a key variable they focus on, which is the fraction of people who completed the program and were placed in the target sector, the target job that they had at the beginning. So I think of this as, do we land you successfully in an internship in the sector where we were seeking to connect you from the get-go? And you can see that there's a strong positive correlation here in the sites and time periods where they're able to get a lot of people, these internships and successful placements. That's where you see the big earnings gains in the longer run. And so what that really highlights, coming back to the program model, is that the second step of that internship, and it echoes the themes of what I've been saying more broadly in this talk, it's not just about teaching people the skills of how to do IT or how to do financial operations, it's also that additional social capital element, that connection, that seems really critical in providing that pathway to upward mobility. We see that here in the context of job training. We see that in a number of other domains: housing vouchers, affordable housing, education. That complementarity seems extremely central. And so, to me, the takeaway from all this is that, hopefully I've shown you from a scientific point of view with modern data sets, we're able to make quite a bit of progress, not just in understanding the drivers of economic opportunity, but also can identify the impacts of these interventions increasingly on scale and hopefully direct resources towards programs that really work. Let me end by noting, especially for the students here, a lot of people often ask, this is all interesting and fun to talk about in the halls of Princeton and Harvard, but does this actually matter in the real world in the polarized time in which we live? And I just want to end by giving you a couple examples where I've been really encouraged to see executive talks in different cities, how engaged people actually are in data like this. When we put out data publicly that rates of economic mobility were incredibly low in Charlotte, or more recently in Philadelphia, there's been a tremendous amount of engagement in trying to invest in the kinds of programs I've been discussing here to improve economic mobility in very data-driven ways. And so I'm delighted that there are so many people here engaged in thinking about these issues, and hope we can make further progress together.